What is the role of terms in algebra polynomial functions? Have you ever wondered how polynomials are built and what makes them tick? Understanding the role of terms in algebra polynomial functions is essential for grasping the basics of algebra. Let's break it down together. In algebra, terms are the individual components that come together to form a polynomial. Each term is made up of a coefficient, which is a number, a variable like x or y, and an exponent, which is a non-negative whole number that indicates the power of the variable. For instance, in the polynomial 3x squared plus 5x minus 7, the terms are 3x squared, 5x, and negative 7. Terms serve several key functions in polynomial functions. First, they are the building blocks of polynomials. Polynomials are created by combining one or more terms through addition or subtraction. The number of terms in a polynomial defines its type. A polynomial with one term is called a monomial, 2 terms make a binomial, and 3 terms create a trinomial. Next, terms help define the polynomial's degree. The degree is determined by the highest exponent found among its terms. This degree is important because it helps classify the polynomial and influences how its graph looks and behaves. Terms also show how variables interact with constants and powers. A term with a higher exponent will have a greater impact on the polynomial's growth rate. This means that as the variable increases, those terms with larger exponents will dominate the behavior of the polynomial. Moreover, because polynomials are sums of terms, they allow for algebraic operations like addition, subtraction, and multiplication. When you perform these operations, you are essentially combining or manipulating the terms according to specific algebraic rules. When polynomials are used as functions, each term contributes to the function's output value based on the input. This means that the overall shape of the function curve is influenced by each term. Understanding terms is vital for breaking down complex polynomial expressions into simpler parts. This makes it easier to perform calculations, analyze functions, and solve equations. Recognizing the role of terms also lays the groundwork for more advanced topics in algebra and calculus. In practical terms, the concept of terms allows us to model real-world situations. For example, we can use polynomials to calculate areas, predict growth patterns, or describe physical phenomena. Each term corresponds to a specific aspect of the relationship we are studying, making it a powerful tool in mathematics. So, the next time you encounter a polynomial, remember that its terms are not just numbers and letters. They are the essential pieces that help you understand and work with polynomial functions effectively.